Prime factorization is breaking up a number into a product of its prime factors. What do I mean by this? Well, a prime number is greater than 1 and has two factors, 1 and the number itself. For example, 13 is prime since its only factors are 1 and 13. That's it. However, 12 is not prime, aka composite, since its factors not only include 1 and 12, but also 2, 6, 3, and 4. My favorite way I recommend prime factorizing a number is with the factor tree method. This means break up a number into factors that you know, and then split up those factors into their own respective prime numbers. Take 42, for example. We know that 42 is divisible by 2 since it's even, so let's split this up into 2 times 21. We'll circle 2 since that's prime and we don't have to split that up further. However, 21 can be split into 7 times 3, and since these numbers are prime, we'll just circle them and stop breaking the numbers down. We're all finished. We can just convey these numbers by multiplying the prime/circled numbers together to get our original number 42. So 42 is equal to 2 times 3 times 7. This is fully prime factorized. Let's try 120. You might want to take this a different route, but I see 0 at the end and know right away that this number is divisible by 10. I'll add little branches to split 120 into 10 times 12, and then I'll work on 10 first, but don't let me forget about the 12 later. 10 is split into 2 times 5, which are both prime, so we can just circle these numbers and forget about that branch. Let's go back to the 12 that we left earlier, since that can be factored up further. I know that 12 can factor into 3 times 4, and 3 is prime, so we can circle that to leave it alone. 4 is equivalent to 2 times 2, which are both prime, so we circle those. To represent 120 in prime factorization, we just use up all of these circled numbers and multiply them together. We can also use exponential notation whenever there's more than one of the same prime factor. You see, our prime factorization is currently 120 is equal to 2 times 2 times 2 times 3 times 5. To write in exponential notation, because this chunk is equivalent to 2 to the third power, by using exponents, we can tidy up our answers by writing 120 is equal to 2 to the third power times 3 times 5. And we're finished. Let's try a fun word problem, and feel free to pause the video and work ahead if needed. Gordon Ramsay wants to follow a recipe that has 340 steps. Sheesh. If he follows the same number of steps per day and the number is a prime number greater than 10, how many steps per day must he follow? Well, the wording of this problem might be a little confusing, but what it's essentially asking for is how many steps per day will he follow? Same number of steps per day means that the answer must be a factor of 340. The answer also needs to be a prime number greater than 10, and since the answer must be prime, we can use prime factorization to break up 340. By using a factor tree, I see the 0 at the end and divide this into 10 and 34. We can focus on the 10 first, which breaks up into 5 times 2, both prime. Moving on to 34, this is an even number, so I divide this to 2 times 17. The answer must be one of these three numbers because the number is prime. But wait, also greater than 10. This leads to the only possible answer being 17, so Gordon Ramsay needs to complete 17 steps per day. I hope this video was helpful in explaining prime factorization. Please leave a like and subscribe if this was helpful, and I'll see you all next Monday. Bye!